key to the future of the universe was discovered long before modern astronomers built their giant telescopes. Back in the 1660s, when Sir Isaac Newton had an encounter with a falling apple and discovered gravity. Newton formulated laws of physics which formed the basis of modern science.
He realized that the same force that takes an apple and pulls it down from a tree towards the earth pulls the moon towards the earth, and in fact pulls the earth towards the sun and pulls the sun towards the center of our galaxy.
But gravity is actually said to be the weakest force. For example, if a person somehow manages to fall off a building, gravity takes a long time to accelerate them during the fall. But electricity and electromagnetism are much stronger, and only take a fraction of a second to stop the fall.
Because the reason you don't go through things is not that the atoms in your body hit the atoms in the table, but rather it's the electric fields between those atoms that stop you. So electricity and magnetism stops you in a fraction of a second, even though it takes gravity all that time to accelerate you.
Gravity may be the weakest force, but it's the force that holds the planets and the stars together. After Newton, perhaps the greatest scientist and mathematician of all time was Albert Einstein. Einstein had been an unremarkable student, and his first job was as a clerk in the local patent office. His general theory of relativity, announced in 1915, explained for the very first time how everything within the universe interacts: space, matter, even time. His calculations told him that the stars and galaxies should exert a gravitational pull on each other and should eventually collapse together in a catastrophic fireball. But they hadn't collapsed, so to make his equations work, he invented a special repulsive force. But it was a makeshift solution, and deep down Einstein knew it.
10 years later, at the Mount Wilson Observatory in California, Edwin Hubble solved Einstein's problem.
Hubble was a World War I veteran and a brilliant lawyer. When he turned his renowned skills to astronomy, he came up with a remarkable discovery that would change the way we view the universe forever. He made the astronomical discovery of the century, that the universe was expanding.
What Hubble found was that almost all galaxies appear to be moving away from us. And this led to the idea that the universe is expanding. Here was evidence for the first time that the universe was actually in motion, that galaxies are moving apart. What that means is that you can essentially extrapolate backwards in time. It's like running a film in reverse. If galaxies are expanding now, then at some time in the past they must have been closer and closer together. And what that implies is that sometime early in the history of the universe, galaxies would have been much closer together. The matter in the universe would have been much denser and much hotter. And this gave rise to the idea of a Big Bang universe.
Astronomers now have calculated that our galaxy is moving away from the other galaxies at 1,000,000 miles an hour. By the end of this video, the universe will have expanded 250 million miles in every direction.
Cosmologists need to find out if there's enough matter in the universe for gravity to stop it expanding and flying apart.
There isn't enough matter, normal matter, to account for all the matter we can weigh in the universe. We can actually weigh the galaxy the same way we weigh the sun and the earth, using Newton's laws. We watch the sun go around the galaxy, and we use gravity to determine how heavy the galaxy really is. And when we do that, we find there's a lot more out there than meets the eye.
Wondering if there is enough matter in the universe to stop it expanding is a prime concern of Professor Stephen Hawking. Born 300 years after Newton, Hawking now holds Newton's old job at Cambridge University. Hawking already knows that the visible galaxies do not produce enough gravity. He now suspects that the universe is full of invisible dark matter.
If the universe continues to expand forever, everything will burn out and decay. The amount of matter we observe in stars and gas clouds is only about 10% of what is required to stop the expansion of the universe. and cause it to collapse again. However, there might be other, dark matter, that we can't see, but which can still affect the expansion of the universe.
There are a lot of people engaged in trying to find out what the universe is, and I think it's mostly the same kind of curiosity that kids have when they're 6 years old or 8 years old. It seems to get beaten out of them in school, but we're sort of the ones that, I don't know, the schools didn't affect or something like that. We're still asking those same questions and still trying to get answers to them.
Here at Cerro Tololo, cosmologists have made a startling new discovery. Bob Kirshner believes that dark matter may not be holding the universe together at all. Scientists now believe that the universe will not collapse in a catastrophic fireball, nor will it coast on serenely. Instead, its contents will speed apart faster and faster until lost in the vast blackness of space.
Now, this is really not anything to worry about, even though it is a kind of a bleak future of an empty, cold, dark universe.
What Kirshner may have discovered is a remnant of the original Big Bang. The inflation that started in the very first second of the universe is taking off again.
What makes cosmology at the end of the 20th century so exciting is that in fact we understand that the largest things in the universe are really determined by the smallest things in the universe. That there's this connection because at the very early Big Bang, the fundamental forces governing the microscopic structure of matter really determined the structures we see today on scales as large as galaxies and superclusters.
The shape of our universe, everything we see around us, was determined when the universe was smaller than an atom and only a fraction of a second old. Our universe is cooling and dying. In 1 billion years from now, our first unmanned spacecraft like Voyager 1 will leave the Milky Way and drift unhindered through the universe. As the universe reaches middle age, even the longest-lived stars will start to burn out.
Our sun has about 5 billion years of life left, and very few stars will still be shining 10 billion years from now. The dead stars will still orbit around the center of the galaxy, but their collisions will gradually cause most of them to fall into a giant black hole at the center.
Suppose we look ahead to when the universe is 100 billion years old. Then it would be a rather dull and dark place, because all but the faintest and most slow-burning stars will have died, so the universe will not only disperse, but all the galaxies will get fainter.
As the universe expands with age, gravity will lose its precarious grip. If you could be there to witness it, you would see absolutely nothing.